Hi everyone, it's Miss Costa here, and in this video I'm going to be taking you through some revision for the paper 3 based on the AQA advanced materials. Okay, so to begin with, we've got a number machine. Now, all a number machine is something that has an input, some functions are operated on it, and then it has an output. So where it says input, that's a number that goes in. The little boxes tell you what operations are being operated on that number, and the output is what comes out. So the first question says work out the output, so what comes out when the input is 10. So you start by putting 10 into your machine. What do you need to do? You need to times it by 2, and then you take 3. So what's 10 times by 2? 20. And then take 3 is 17. So the output when the input is 10 is 17. Now for the next question, we're being asked to work out the input when the output is 8. So what we need to do is go to our output and write 8 there, and then we have to go in reverse. So with function machines, if we're working with the output, we go we do the reverse of everything in order to get back to the input. So the reverse or the inverse of taking away 3 is adding 3, and the inverse of timesing by 2 is dividing by 2. So we're going to do 8 plus 3, which is 11, and then we're going to divide that by 2. So 11 divided by 2 is 5.5. So when the output is 8, the input will be 5.5, and that's how we do our number machines. Now here we're being asked to simplify fully. So what's really important when doing questions like this is to know that there's a difference between an x squared term, an x term, and then just a single a number. Okay, so when you're dealing with x squared terms, it's helpful to think of them as like an area, so like a square, because that's essentially what x squared is. It's a number multiplied by itself. And think of x as like a length. So if we rewrote this expression in terms of x squared and x, what would I have? Well, I've got 3x squared, so 3 lots of boxes, 4 lengths, 4x, take 5, take 2x squared, so I'm going to get rid of 2 boxes, plus 8x, 1, 2, 3, 4, 5, 6, 7, 8, take 12. Okay, so that should help you realise which ones are like terms. So you've got your x squared, your boxes are like terms, so you've got 3x squared, take 2x squared. So if you had 3 boxes and you take 2 away, you're left with just 1x squared, which we'd write as x squared. Then you look at your lengths, which are your next like terms. So you've got 4x plus 8x. And 4x plus 8, 4 plus 8 is 12. So you'd be left with x squared plus 12x. And then finally, you've got just your numbers. So minus 5, take 12. Remember, the sign always belongs to the term after it. So the positive or the minus always belongs to the value after it. So that negative belongs to the 12. That negative belongs to the 5. So minus 5, take 12. You can, it's calculator, so you can type it into a calculator or just visualize a number line. It's minus 5 degrees. And you take 12. So when you're subtracting, you always go down the number line. So minus 5, take 12 would give you minus 17. Okay, then we've got substitution. So all substitution means is replacing a value with the value you've been given. So like with football, when you bring on a substitute, you replace one player for another. So here we're replacing the letter with a value that we've been given. So we're told that A is -2, B is 3, and C is -6. So what we want to do is first think about what's the algebra that's going on here. So 2A, that means 2 times by A. Then you're going to add B, and then you're going to take 3z. What does 3z mean? It means 3 multiplied by z. So it really helps to write out what's happening with the algebra first. And then just substitute your values. So you know that A is -2, so that will be 2 times -2, plus B, which has a value of 3, and take 3 times by z, and z is -6. So 2 times -2, let's move that up here, is -4, and then you've got +3, and then minus 3 times -6 is -18, so you've got -18. And remember, when there are two negatives, when you're subtracting a negative, it's the same as adding. Like if you're taking away like ice cubes from a cold water bath, you're actually making it warmer because you're removing the cold. So subtracting a negative is the same as a positive, or just when you see two negative signs next to each other, you turn them into a positive. So that would become -4 + 3 + 18. So 3 + 18 is 21, and then 21 take 4 gives you 17. So the answer for that one would be 17. And then here we've got a nasty one, but again, this is a calculator paper, so just plug these values into your calculator. So x is 2/3, y is 3/5. So let's add them together first. So I'll just use a calculator. So type that into your calculator. So 2/3 plus 3/5 is 19/15. So you're going to do, oh, I didn't even read the question. So this is where they're going to try and get you out. Okay, remember, BIDMAS always applies to everything, absolutely everything. So it says work out the value of x plus y times by z. So actually what you're going to have to do first is multiply x times by z. Okay, so BIDMAS always is always an operation. So here you're going to have to do this part first. So 3/5 times by -3/4. So once again, just type that into your calculator. And if you like, on your calculator, you've got a fraction button, so just press that button and then you can use your fractions. So 3/5 times by -3/4 would give you -9/20. So you can rewrite this as 2/3. What did I just say? It was -9/20. Take 9/20, because if you're adding a negative, you're subtracting. So type that into your calculator too. 2/3 take 9/20 gives you 13/60. Okay, so all you're doing here, it just looks a little bit more confusing because it's got fractions, but you're doing exactly the same thing, just and you have a calculator, so just plug the numbers in. All substitution means is replace that value with what you've been given. Okay, now we've got a formula. So here is a formula for the amount of water needed to make some icing sugar. W is the number of cups of water needed. P is the number of servings to be made. How many cups of water are needed to make 8 servings? So W is cups of water needed, and P is the number of servings. So we know that we're going to substitute the value we've been given for P. So P in this case is 8. So I'd write W is 1.2 times by 8, because 1.2p means 1.2 times by p, and then add 0.6. So once again, just plug that into your calculator. 1.2 times 8 plus 0.6 is 10.2. So W is 10.2. So you need 10.2 cups of water. And then how many servings of cake can be made with 15 cups of water? So it's the cups of water you've been given now. So where we see W, we're going to write 15. And 15 is 1.2p plus 0.6. Now, sometimes with the formula, you're going to need to rearrange it. So in this case, that's what we need to do to find the value of p. So we take 0.6 from both sides. So 15 take 0.6 would leave you with 14.4 equals 1.2p. What does 1.2p mean? It means 1.2 multiplied by p. So the inverse to get p on its own is we divide both sides by 1.2. And then 14.4 divided by 1.2 is 12. So p would be 12. So therefore, how many servings of cake can be made? 12. Okay, so shown below is the graph of y equals x squared plus 3x takes 7. It isn't actually shown. So let's just really quickly work that out. So we've got the x values of -6, -4, -2, 0 and 2. And we don't know what our y coordinates are. We can figure those out. So if you are given a quadratic, it doesn't say that drawing quadratics is coming up, but you know, things can come up that aren't stated. So if you're looking to find the roots and the turning points, there is a chance it might come up. So what do we do to draw a quadratic? We look at what x values have been given to us. So can you see how -6, -4, -2, that's the x-axis that we've been given. So we use that in our table of values, and then we just substitute those values into it. So -6 squared, that would be 36, plus, let's write it out. So -6 squared plus 3 times 6 takes 7. I'm just transferring this, I'm substituting into this. So I've got -6 squared is 36, 3 times 6 is 18, takes 7. So 36 plus 18 takes 7 is 47. So that is way too big and that won't fit on the graph. Try the next one, -4 squared plus 4 times 3, or 3 times 4 I should have written, takes 7. So 16 plus 12 takes 7 is 21. That also won't fit onto the graph. You know what, just for simplicity, because I think I'm not very, I just didn't pick a good equation. So imagine this, the graph that you're given, this is what it looks like, okay? There we go, that's it. Now to write down the roots of the equation, so if you've been given a graph, chances are you're going to be given it. If not, you're going to draw it, and if you're going to draw it, they're going to give you values that actually go onto the graph. So roots are literally where the graph crosses the x-axis. So where the graph crosses the x-axis. So in this case, all you have to do is find the coordinates of where the graph crosses the x-axis. So let's prop that out actually, because oh no, where is it? So I'd say, and this is just a really rough one, so that coordinate over here, let's say would be 2, 0. So you write the full coordinate to find the root. And then that one, let's just say it's -4, 0. If you do get a graph and it's quite a big one, the chances are that it might not be through an exact coordinate. So it might be like through -1 and -0.5, and it might cross there. So you need to be really accurate. I'm just showing you because this is a made-up graph because I didn't draw the graph on because I forgot. So roots are literally just where the graph crosses the x-axis, and then the turning point is exactly what it says it is. So the turning point is the coordinate where the graph like turns. So here, if that's -2, that would be roughly -1. This isn't drawn very well. Let's just estimate it to be 0.3 and 2. So the coordinates would be -0.3 and 2. This isn't perfect, but you get the point. Roots are where the graph crosses the x-axis. Turning point is the coordinate where it actually physically turns. Okay, arithmetic sequences. Now, an arithmetic sequence is a sequence that has a constant, it increases or decreases by a constant value. So it's where there's going to be a constant difference. Like here, if we look at this one, How do you get from 11 to 16? You add 5. 16 to 21, you also add 5. So you need to use 3 of the numbers you've been given to make a different arithmetic progression, which just means that the difference between your terms needs to be equal each time. So let's pick some. Okay, so let's say 40 and 28. The difference between them is 12. So is there something that has a difference from 28? 28 take 12 would give us 16. So the numbers could be 16, 28, and 40. I mean, there are loads of other combinations too, but you just need to pick 3 numbers that have a constant difference between them. So describe the rule, you add 12 each time. And the rule is just what's the difference between each terms. It's not asking you for the nth term, which is the rule of the sequence. That's something different, which we'll come on to. Just describing the rule is generally the term-to-term rule. How do you get from one term to the other? Okay, here we've got a geometric sequence. So arithmetic is where there's a constant difference by adding or subtracting. A geometric sequence is where you can get from one term to the other by multiplying or dividing. So how do we think we're getting from each term, from one term to the next? Well, they're getting smaller. How do you get from 120 to 60? We could have said you take 60, but then we know that that doesn't apply because 60 takes 60 gives us 0. So we should notice, okay, it doesn't look like an arithmetic sequence because it's not going down by a constant. So therefore it must be being divided or multiplying by something. The numbers are getting smaller, so they must be being divided. And this one's quite a simple one. 120 divided by 2 gives you 60. 60 divided by 2 gives you 30, and so forth. If you didn't know what the difference is, then you could have typed into your calculator 120 divided by 60, and that would have given you 2, which gives you the division that you'd need. So each term is being divided by 2. We've been given 1, 2, 3, 4, 5 terms, and we need to work out the 6th term. So if we know it's being divided by 2 each time, 7.5 divided by 2 is 3.75. I'm just going to double check because okay, so 6th term would be 3.75. And you're being asked to describe the rule of the sequence. Well, we've already spoken about that. Divide the previous term by 2. You could just also write divide 2. And last little topic for algebra is the nth term. So here we've been given a slightly nasty nth term, but it's fine because all you do with an nth term is substitute something in, and we've already covered substitution. So which term in the sequence is the first to have a value greater than 60? So this is the nth term, and I want my nth term to be equal to, well, I want it to be greater than 60. So let's figure out what it needs to be in order to be 60. So let's rearrange the equation. So what we're going to do first, we're going to multiply both sides by 3. So n squared would be 60 times by 3 is 180. And then let's do the square root of both sides, because that's the inverse of squaring. So the square root of 180 is 13.416. Okay, so we know that the 13th term, so that basically gives us a clue. It's going to either be the 13th or the 14th term. So let's try substituting 13 into the equation. 13 squared divided by 3. So 169 divided by 3 is 56.3. So it's not the 13th term. Therefore, it must be the 14th term. So 14 squared divided by 3 is 14 squared divided by 3 is 65.3 recurring. So the 14th term has a value of 65.3. That is the first term to have a value greater than 60. The 13th term has a value of 56.3, and terms need to be integers, whole numbers. You can't have like a decimal term. You can't say the 13.416th term. You either come first and erase 13th and erase 14th in a row, so you don't come 13.41. So terms are always integers. Okay, now here we've got a different sequence, so let's just get rid of this. 18, 21, 24, blah, 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 and we need to figure out the nth term. So let's just write it out a little bit bigger. What we want to do when working out the nth term is find the constant difference. So how do you get, what's the difference between 18 and 21? Difference between 18 and 21 is 3, 21 and 24 is 3, and 24 and 27 is 3. So this tells me that I am going up in the 3 times table. So whatever your constant difference is, that tells you the times tables that the sequence is using. Now, if it was the 3 times tables, we know the 3 times tables begins with 3, then 6, then 9, then 12. So what we want to do is compare the times tables, the 3 times tables, with this pattern. So essentially, it's the 3 times tables, but a certain amount larger. So how do you get from 3 to 18? You add 15. How do you get from 6 to 21? You add 15. 9 to 24, you add 15. So therefore, my sequence is the 3 times tables. That's why I wrote 3n. And whatever times tables is, you write that in front of the n, because that represents like the times tables it's going up in. So 3n, and then you find the difference between the first term of the original times tables and your pattern. So the first term of the 3 times tables is 3, first term of your pattern is 18, and the difference is 15. So you just say 3n plus 15. And that is algebra, all done. Okay, so next we've got number. So here I'm being given a place value question, and place value just means what is the value of the digit and the position it is in the whole number. So here, what is the value of the digit 3 in the answer to 6,300 divided by 10? Now be really careful with questions like this, because people always jump to it and they're like, oh, the value of the 3 here is the 100, so that the value is 300. Nope. It's asking for the answer. So first we have to work it out. So 6,300 divided by 10, obviously you can do it on a calculator, is 630. So then we look at the position of the 3. It is in the tens column. So therefore I just say the value of the digit 3 is 30. Generally, sometimes you make sure you're specific. So don't just say tens. It's the value of the 3 isn't tens, it's 3 tens. So make sure you say the actual value, not just the place value holder. Okay, then we've got factors. So factors are just numbers that would multiply into your given number. And it's really helpful to do them as factor pairs. So the factors of 24 always start with 1, because 1 is always going to be a factor of a number, and 1 times by that number. So you've got 1 times 24 makes 24. Then try 2, which is the next number. So 2 is 2 a factor of 24. You've got a calculator, you can divide it if you're not confident with just these divisions. 24 divided by 2 is 12. So I know that 2 is a factor. Then let's try the next number, 3. 24 divided by 3 is 8. So I'd write 3 times by 8. Then try the next number, 4. Just 4 going to 24. 24 divided by 4 is 6. So I'd write 4 times 6. Then I could try 5, but you know it's not going to be a factor of 24, because it does not end in 5. Then we could try 6, but hopefully you notice that 6 already appears on this side. So once a number on your first side matches a number on the second side, you know you've gone through all of the factors. Because if I kept going, I would have 6 times 4, then I'd try 7, 7 doesn't go into it, then I'd try 8, I'd get 8 times 3. So we don't need to do that. We have all of the factors, and to write them out nicely, you can write them in a nice list. Just go down this way to write them in order. So 1, 2, 3, 4, and then go up this way. 6, 8, 12, 24. And that just ensures that you write all of the factors. People so frequently get this question wrong. they get incomplete marks because they're like, oh, I know all the factors. They just hurry to write them down and they missed one out by accident. The question says all the factors, not most of them. So I would highly recommend doing this factor pair method. Okay, multiples. Now a multiple is literally just that numbers times table. So every number that would appear in that numbers times table. So write down two numbers that are multiples of 3. So multiples of 3 literally just means the 3 times table. So 3, 6, 9, 12, 15, 18, 21, so forth. Multiples of 3 and multiply to make 243. Okay, so out of the 3 times tables, you just need to find a number that multiplies to make 243. Well, 243 divided by 3, what does that give you? 81. So you could just say 81 times 3. Or, let's try 9. 243 divided by 9 is 27. You could say 9 times by 27. So, obviously, and then you know that they're both multiples of 3. So, any of these really. Let's try 243 divided by 12. Does that work? Nope, that's not a whole number. 243 divided by 18. Does that work? Nope. Well, some of these numbers are going to work. Okay, so we've got 2 already. You only need to choose one pair. But a multiple is just that numbers times tables. Okay, highest common factor. Right, so the highest common factor, what's the best way to do this? So it's calculator paper. So, you can choose, yeah. So let's do it just the factor way. So 96, 1 times 96, then try 2 times 48, then try 3 times 32, then try 4, so 96 divided by 4 is 24, so 4 times 24. 5 won't go into it because it's not on the 5 times tables. Then let's try 6, so 96 divided by 6 is 16, so 6 times 16. Try 7, nope. Try 8 times 12, try 9, it's not going to go into it, but try it anyway. 10 won't go into it because it needs to end in a 0. 11, nope. And then we're back to 12. Okay, so we know we've exhausted all our numbers. So the factors of 96 are 1, 2, 3, 4, 6, 8, 12, 16, 24, 32, 48, 96. And then what we need to do, sorry, I've got really itchy nose. What we need to do is do the same for 108. So we've got 1 times 108, 2 times by 54, 3 times by 108 divided by 3, 36, 108 divided by 4, 27, 5 won't go into it, 108 divided by 6, 6 times 18, 108 divided by 7, 108 divided by 8, 108 divided by 9, then we've got 9 times 12, 108 divided by 10 won't go, divided by 11 won't go, 108 divided by 12. Okay, so then we're back to the original, so we know that we've exhausted all of our numbers. So the factors of 96 are here. The factors of 108 are 1, 2, 3, 4, 6, 9, 12, 18, 27, 36, 54, and 108. And we're looking for the highest common factor. So out of these factors, what is the largest number that is common to both of them? And from what I can see, that would be 12. So 12 is the highest common factor of those two numbers. Now you can do it using the Venn diagram method. If you know that method, that's great, but I don't want to confuse you. It's a calculator paper, so it's very simple to just go down and work out the factors that way. Okay, error intervals. Okay, so a number x is rounded to 2 decimal places. 8.47. Okay, so to 2 decimal places is this digit here. So we need to think, if it's been rounded to 2 decimal places, what's the smallest possible number it could be before it got rounded down to 8.46 and before it got rounded up to 8.48. So we're looking for the halfway point so that it doesn't get rounded down to 8.46. So that would be 8.465. And the largest number it could possibly be would be 8.4749 recurring. But because that is quite long to write, instead we write it as an interval. So the reason we write it as an interval is because we say that x cannot be exactly 8.475, but it can be anything up to 8.475, which is where this inequality means. So that means x is less than 8.475 and 8.465 is less than or equal to x. So x could be 8.465 because 8.465 rounded to 2 decimal places would round to 8.47. So it could be equal to it or it could be greater. So x lies in between these. So your error interval is just going to be 8.465 is less than or equal to x, which is less than 8.475. Generally, the trick is to, like, whatever your number is, you take like 5, add 5. So you take away 0.05005, you add 0.005. But the best way is to just write to 2 decimal places what are the numbers surrounding 8.47 and then find the halfway point between those. Okay, calculating with indices. So 6 to the power 5, what does that mean? It means 6 times 6, 6 times by itself 5 times, so 1, 2, 3, 4, 5, 6, plus 7 cubed. Okay, now the laws of indices don't apply here because in order to use the laws of indices, you need to have the same base power. So if it was something like 6 squared times by 6 cubed, well, that just means 6 times 6 times 6. Like that. So that I could add those. I could add the powers because they have the same base. However, here 6 and 7 are not the same base. The base is like the big number, that's the little indice, that's the power. So if they do not have the same base, you can't use the laws of indices, and also you're adding them anyway, so the laws of indices wouldn't apply. So we just have to actually calculate this. So you've got your calculator, you type in that little x squared thing, you type 6 to the power 5, and if you don't know how to use that, then just type in 6 times by 6 times 6 times 6 5 times. So that gives you 7,776, and 7 cubed is 343. So you just add those together and that's your answer. So 8119. If you do have something that has the same base, then you can use the laws of indices. Okay, money problem. So Rosie has an equal number of 5p and 20p coins. The value of her 5p coins is £1.40. Okay, so we know that she has 5p coins that add up to £1.40, which is 140 pence. So what we can do is divide that by 5 to see how many 5p coins she must have. So 140 divided by 5 is 28. So she has 28 5p coins. And if she has an equal number of 5p and 20p coins, she must have 28 20 pence coins. So what would the value of her 20 pence coins be? Well, 28 times by 20 is, calculator time, 28 times by 20 is 560. So 560 pence or £5.60. and we want to work out the total value. So we know that her 5p coins are £1.40 and her 20p coins are £5.60. So that would give us 700p, which is £7. Okay, so you use the fact that you know that her 5p coins add up to £1.40 to figure out how many 5p coins she has. And finally, units of measure. What is 340 millimeters in centimeters? So 1 centimeter is 10 millimeters. So if I use that little thing, 1 centimeter is 10 millimeters, and I have 340 millimeters. So it depends how you use these, whether you prefer going this way. So how do you get from 340 divided by 10 is 34. So to get that way, you would divide by 34, or to go from millimeters to your amount, you would times by 34, which means on this side you would times by 34. So that would be 34 centimeters, or you might prefer doing it across. So how do you get from millimeters to centimeters? You divide by 10. So you would have had to divide this by 10 as well. So 340 divided by 10 is 34. You choose whichever way works best for you. Okay, so for this question, it's just a matching question, naming shapes. Hopefully feel familiar with all the 2D and 3D shapes. So the first one, it's got 6 sides. That would be a hexagon. A cone is a 3-dimensional shape, and it looks like, well, an ice cream cone. And then over here, you've got a triangular prism. Okay, say the name of this regular polygon. Now, a polygon is just a shape, a many-sided shape. So a shape that is made up of straight sides only and has more than 3 sides. This is a 5-sided shape, so that is called a pentagon. Work out the size of angle X in this regular pentagon. Now, the fact that it is regular, so any regular shape, the key thing you need to know is that regular shapes have equal sides. All sides are equal, and all angles are equal. So in this regular shape, we want to figure out what the angles add up to. Now, with polygons, all you do is you think to yourself, okay, well, how many triangles could I fit into this polygon? Start from one vertex and go to every other one. You could fit 3 in them. What do you know about the angles in a triangle? You know, the angles in a triangle add to sum to make 180 degrees. So each triangle inside this pentagon would give you angles of 180 degrees. You've got 3 lots of them. 3 times 180 is 540 degrees. So you know that the sum of the angles is 540. You know there are 5 angles and they are all equal. So therefore you'd do 540 divided by 5, which is 108, I think. Let's just double check. 540 divided by 5 is 108. Okay, so that's how you'd work out the angles of a regular polygon. Think to yourself, how many triangles can fit into it? Generally, I mean, not generally, but always, however many sides there are going to be 2 less triangles. It's like a 5-sided shape had 3 triangles. A 3-sided shape has 1 triangle. It's called a triangle. Okay, draw the lines of symmetry on this hexagon. So lines of symmetry are literally, if you put like a mirror halfway, wherever you think your line of symmetry is, would it reflect back on itself? Or if you folded the shape, would it fold onto itself? So we've got a line of symmetry here, we've got a line of symmetry there, we've got a line of symmetry there, we've got a line of symmetry there, and we also have a line of symmetry here and there. Generally, if it's a regular shape, its lines of symmetry are going to be like the amount of sides that it has. Okay, so rotational symmetry, that just means when you rotate the shape around, how many times does it, after you've rotated it, how many times does it fit onto itself? So you want to shade one more square so the shaded shape has one line of symmetry and no rotational symmetry. Okay, so it doesn't rotate upon itself. So if we shaded a square in here, then that would give me a line of symmetry going down that way. And if we rotated it, so if we rotated it once, it would look like this. If we rotated it again, it would look like that. And if we rotated it again, it would look the opposite of this. So it has no rotational symmetry. It only fits onto itself when it gets back to its original position. Okay, so the semicircle below has a radius of 6 centimeters. Find the perimeter. So in order to find the perimeter, remember perimeter means all the way outside of the shape. So that's, people always get this question wrong because they forget the diameter, but perimeter just means all the way around the outside of the shape. So what is the formula for the circumference of a circle, which circumference is just the fancy word for the perimeter of the outside of the circular part? So in this case, this part here. The formula for the circumference of a circle is pi times by the diameter. Now this would be for a full circle. So if this was a full circle with a radius of 6 centimeters, what would I do? I would do pi times by 12 because the radius is half of the diameter. So all of this distance here must be 12 centimeters. So I do pi times 12, which is 12 pi. Let's just type that into a calculator. 12 times by pi is 37.699, blah, blah, blah. However, that would be for the full circle. This is half a circle. So I want half of this, therefore I half my answer by 2. So divided by 2 is 6 pi, which is 18.8495, blah, blah, blah. So this part here, the circumference bit, the circular part, is 18.8495. That's this part, but remember perimeter is all the way around the outside of the circle, so you add the 12 centimeters of the diameter as well. Therefore the perimeter of this circle would be 30.85 centimeters rounded to 2 decimal places. Okay, next we've got find the surface area of this cylinder. So the surface area of a cylinder, if you just imagined what it would look like if you, like, I'm just trying to think if you unraveled like a toilet roll, if you just cut it, it would unravel and it would be a rectangle. So this part here of a cylinder is just going to be a rectangle. Its height is going to be whatever you're given, and its length is going to be the circumference of the circle. Okay, because if you imagine like the toilet roll is like circle, you unravel it, so the length of that circle is the length of the rectangle. So, and then you've also got the top bit of the cylinder, and there would be, unlike a toilet roll, which obviously has a hole, this is like a closed shape, so you've got 2 circles as well. Now, area of a circle is pi times by radius squared. So in this case, the radius we're told is 3. So we do pi times 3 squared, which is 9 pi. So let's leave it in pi for now, and then we can add it. So the area of each circle is 9 pi. Now, what's the circumference of a circle again? Circumference is pi times by the diameter. Now we know the radius is 3, so the diameter will be 6. So this rectangle would be 6 pi times by 12. And what's 6 pi times by 12? That's 72 pi. Okay, so the area of everything is 72 pi plus 18 pi. I just simplified these two. So 72 plus 18 is 90 pi. And then just type 90 times by pi into your calculator, which is 282.74 centimeters squared, rounded to 2 decimal places. Don't be afraid to work in pi. It just makes your life a lot easier. If you wanted to, you could of course have written that as decimals and worked that way. It doesn't matter. It's just a lot easier to leave it in pi because it's less calculations. Okay, so the volume of... Okay, so with the volume of the sphere, you are going to be given the formula for it. So the formula for the volume of a sphere is 4/3 times by pi times by radius cubed. Okay, so you'll be given that as part of the question. So don't panic about needing to memorize it. Now work out the volume of the sphere. It's just a simple substitution. So we've got 4/3 times by pi times by radius cubed. What's the radius? 4. Okay, so let's just do it bit by bit. 4/3 times by pi times by 4 cubed. What's 4 cubed? 4 times 4 is 16. Times by 4 again is 64. And you can... So depending on your calculator skills, so when you've got something like this, you can just write it all together. So you've got your little fraction button. You'd write 4/3 times by pi. So pi is shift times by 10 times by 64. Okay, so that would give you 268.0825731, round to 268.08 centimeters cubed. Another way you could do it is by just leaving it as fractions, and remember to turn anything into a fraction, you just write it over 1. So you could have done 4 times pi times 64. So let's just do that quickly. So 64 times by 4, so that would give you 256 pi over 3. So you could have simplified it first, up to you depending on how confident you feel. Okay, next we've got trigonometry. So the key thing to remember with trigonometry is SOHCAHTOA. Hopefully you know what that all of that represents. So write it out, SOHCAHTOA, to help you remember. And all that means is that you've got sine theta is opposite over hypotenuse. Cos theta is adjacent over hypotenuse, and tan theta is opposite over adjacent. Okay, so what does all of this mean? Your triangle, it all of its sides are in relation to one another. So you need to write this out first, just write that out, and then we'll go through it bit by bit. Now you've got your triangle. What does the opposite side mean? That is opposite to the given angle. Okay, so the opposite side is the one that is opposite to your given angle. So this is your given angle. So this is going to be your opposite side. Now the hypotenuse, that is the side opposite the right angle. Okay, so the hypotenuse is always going to be the side opposite the right angle. So your hypotenuse will be this length here. And then adjacent, all that means, adjacent just means next to. So the side next to the given angle. Okay, so the adjacent side is going to be here. Now, where people always go wrong is they label the sides wrong. So it's really, really important. The first thing you do when you see this triangle, you label the sides. Which one's the hypotenuse? That's super easy because it's opposite the right angle. Which one's the adjacent? It's the one that is next to the given angle, and the opposite is the one that is opposite the given angle. Okay, so Now we've got all of this, what we have to do is choose which one of our trigonometric identities we're going to use. So we've been given x, we're trying to find x, so we know we need to use the opposite. Oh, I think we should have been given another side as well. Oops. I'm just going to make it up. Okay, so let's say that we've been given this side here is 12. Okay, so we've been given the opposite and the adjacent. So which of the trigonometries have O and A, the opposite and the adjacent? That's tan. So that's why I write SOHCAHTOA, so we can quickly remember which one we need to use. And then I use this. So let's write this out. So tan theta equals opposite over adjacent. Now I'm just going to rub this out for a bit of space. So what does theta, that little circular thing, mean? That just represents the angle. Okay, so that theta thing is just the angle. So what's the angle that I've been given? 35. So I'd write tan 35 degrees equals opposite, which is x, over adjacent, which is 12. Okay, so I just substitute the values into this equation. Once I've substituted them, all I need to do is rearrange the formula so that I figure out the value of x. So I'd multiply both sides by 12. So 12 tan 35 gives me the value of x. So you just type that into your calculator. 12 tan 35, close the bracket, gives you 8.40 to 2 decimal places. Oh, no, it wants it to 1 decimal place, so 8.4. Okay, and that's how we do that. Now I will go through another example. If you're trying to work out the angle, so you use the same thing. You write out SOHCAHTOA just to help you remember. So just write that out and then label each of your sides. So the easiest side is the hypotenuse. It's always the one opposite the right angle. Then you've got your angle, and the side that is opposite that is going to be the opposite. And then your adjacent is the side that is next to your given angle. Remember, the given angle is the one that is not the right angle. Okay, so which two sides have we been given? Well, we've been given the hypotenuse, which is 11, and the adjacent, which is 8. So A and H, that would be K. So write out the little formula. So cos theta is adjacent over hypotenuse. And let's substitute what we know. Well, we don't know the value of x, but we'll just write cos x equals adjacent, which we're told is 8, over hypotenuse, which is 11. Okay, so cos x is 8 over 11. Now, to figure out what x is, we're going to need to divide both sides by cos. However, if you try doing that, 8 over 11 divided by cos, it comes up with syntax error. So what you do instead is you, the calculator has saved dividing by cos into itself. So we press shift. If you're trying to divide by cos, tan or sin, you press shift and then cos. Okay, so you press shift, cos, so that comes up. So shift cos, and then you type in your fraction, which is 8 over 11, like that. Okay, and then you get your answer. So shift cos, go away. 8 over 11, x is 43.3417, blah, blah, blah. But let's just round it to 2 decimal places. It says angle of elevation is 43.34 degrees. I didn't bother talking about the ladder thing, but yeah, Reese places a ladder of length. So this length here is 11. 8 meters away from the wall. This is the wall here. Okay, Next question. Compound shape is made using a rectangle and a triangle, and I need to find the perimeter. So this is a little bit of a sneaky one because they haven't given you the exact measurements. So you're going to need to use trigonometry to help you out. So over here, you've got right out SOHCAHTOA again. You're obviously going to need to figure out what this length here is. We don't know what that length here is. However, it's going to be the same length as this length here, which is one of the sides of the triangle. So let's label the triangle. This is going to be the hypotenuse because it's opposite the right angle. This will be the opposite because it's opposite your given angle. And this is going to be the adjacent. So we're trying to find the hypotenuse, the opposite side. Okay, so this is the side we're trying to find. So we're working with the opposite and we've been given the adjacent. So opposite and adjacent, that's tan. So we write out tan theta equals opposite over adjacent. That's just the formula. And then we substitute. We know the angle is 38. So tan 38 equals opposite x over adjacent, which is 5. What do? We rearrange the formula. So multiply both sides by 5. So 5 tan 38 equals x. So type that into your calculator. 5 tan 38. And that is, it tells you that x is 3.906, blah, 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 blah. So let's just round that to 3.9. So that would be 3.9. Okay, so we obviously don't include it in this line because that's not part of the perimeter. Perimeter is just the outside of the shape. But we've used trigonometry to figure this side out. So that's 3.906, 428,133, blah, blah, blah. Okay, so we know that this side as well would be 13 because opposite sides of a rectangle are equal. We know that this is 5 centimetres. So all that's left to figure out is this length here. So we're going to need to use trigonometry again. So we know that this side here is 3.9. Label your triangle. It's going to be exactly the same as it was before. So opposite and hypotenuse. Now, we're trying to find the hypotenuse. So over here, we've got the hypotenuse we want, and we've been given the adjacent. So A and H, that's K. So cos theta is adjacent over hypotenuse. So what's theta? The angle is 38 degrees. Adjacent is 5. And the hypotenuse is x. That's what we're trying to find. So this is where it gets a little bit trickier. We've rearranged the formula. Multiply both sides by x. So you say x cos 38 equals 5. And then what we're going to need to do, we're trying to isolate x. So this is where we divide both sides by anything remaining, which is cos 38. So we'd say 5 divided by cos 38. So let's type that into our calculator. 5 over cos 38 is 6.345091, blah, 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 blah. Okay, so this length here would be 6.34, okay, 6.345, so we'd round that to 6.35. Okay. So therefore, the perimeter would be all of these sides added together. So 13 plus 3.9 plus 13 plus 5 plus 6.35. Let's just quickly add those together. Plus 5 plus 13 plus 3.9 plus 13 is 41.25. I don't know if I added them all. Did I add them all? Let's try one more time. 6.35 plus 13 plus 3.9 plus 13 plus 5 is 41.25. Okay, and that is the perimeter of this tricky compound shape. Okay, then we've got parallel lines. So a key thing that we want to know, a key angle fact that we want to know, is this, which is that vertically opposite angles are equal. And that will help us with this. So vertically opposite angles are if they form, like if you two straight lines meet, the angles that are opposite each other, vertically opposite, are going to be equal. So those two angles would be equal and these two angles would be equal. So we're probably going to want to use this when it comes to angle facts in a parallel line. Okay, so find the values of angles x and y. Another thing that you need to know is that alternate angles are equal. So over here, alternate angles look like this. So they are on alternating sides of the transversal. The transversal is just the name of this, the line crossing through the two parallel lines. So alternate angles are on alternating sides of the parallel lines. I'll show you how else they could look, because they're not always going to be, the parallel lines aren't always going to be like that. So here's your parallel lines. If that was an angle here, this over here would be its alternate angle. Okay, so therefore, let's apply this to here. So here you've got your parallel lines, you've got an angle here. Its alternate angle would be over here. So that must mean that x is 52 degrees. Okay, because alternate angles are equal. And then you've got these angles here. Hopefully you recognise that they're vertically opposite. So if that is 38 degrees, this also must be 38 degrees. So x is 52 and y is 38 degrees. And the reason for x is because alternate angles are equal. So if they say list your reasons, you need to list those. So alternate angles are equal. And for this one, it is vertically opposite. So list the reasons. So vertically opposite angles are equal. Alternate angles are equal. And finally, we've got some vector arithmetic. So vector arithmetic is nothing to be scared of. It's literally just directions and movements, and it's really simple to add. You just add it as you would anything else. So you're told that you want to work out 2f. Now you know that f is minus 2, 3. So 2f would literally be this multiplied by 2. So multiply the top part of the vector by 2. Minus 2 times 2 is negative 4. And 3 times 2 is 6. So therefore, 2f would be negative 4, 6. Okay? Then you're subtracting g. So g, we've been told, is 4, 2. So that would be for negative 2. So once you've worked out what your vectors are, you just subtract them. So you subtract the top part, the x values, and the y values. So negative 4, take 4, is negative 8. And 6, take negative 2. Remember, when you've got a negative, when you're subtracting a negative, that becomes a positive. So 6, take negative 2 is positive 8. Okay, so that's how we do that vector. That would be negative 8, 8. You work out what two lots of it would be by doubling it. And then you just subtract them. Subtract the top parts and bottom parts. And then you've got 3g. So if g is 4, 3g, 3 times 4 is 12. 3 times negative 2 is negative 6. So 3g would be 12, negative 6. Take away 2g. I think that's supposed to say 2f, but whatever, let's go with 2g. So 2g would be 2 times 4 is 8. 2 times negative 2 is negative 4. So 12 take 8 is 4. Minus 6 minus minus 4. Remember, that will become a plus. So minus 6 plus 4 is negative 2. And that's it. That's all you need to do for vector arithmetic. Okay, so ratio. We are told that a 5p coin weighs 3.25 grams. That's actually how much it weighs. What would the weight of £3 worth of 5p coins be? Okay, so we know that £3 is equivalent to 300 pence. So how many lots of 5p fit into 300? So 300 divided by 5 would give you 60. So 300 divided by 5 is 60. So we've got 60 lots of 5p coins. And what would the weight of £3 of worth of 5p coins? Okay, so we want 60 lots of 3.25 grams because each 5p coin weighs 3.25 grams. So let's multiply that. 60 times 3.25 is 195. So 195 grams is what our answer would be. However, they say that they want their answer in kilograms. So we know that 1 kilogram is 1,000 grams. So how do you get from grams to kilograms? You divide by 1,000. So what we're going to have to do is divide this by 1,000. So 195 divided by 1,000 is 0.195. So the final answer would be 0.195 kilograms. Okay, next we've got converting time. So how many seconds are there in 2.5 days? First of all, let's say how many hours are there. So we know that in 1 day, there are 24 hours. So in 2 days, there would be 48 hours, and half a day would be half of 24, which is 12 hours. So 2.5 days is 48 plus 12, which is 60 hours. Okay, so we want to work out how many seconds there are in 60 hours. So we know that 1 hour is 60 minutes. So 60 hours with times by 60. 60 hours would be 60 times 60, 3,600. So 60 hours would be 3,600 minutes. And we know that in 1 minute, there are 60 seconds. So 3,600 minutes, 1 minute is 60 seconds. We want to turn into seconds. So what are we going to times? We times minutes by 60 to get to seconds. So we times 3,600 by 60. 3,600 times by 60 gives me 216,000 seconds. So 216,000 seconds. So remember, key things are 1 day has 24 hours. 1 hour is 60 minutes and 1 minute has 60 seconds. So we would have done 60 times by 60 to get to the minutes, and then times by 60 again to get to the seconds. Okay, share into a ratio. So Shania is 5 years old, Michaela is 6 years old, and Annie is 7 years old. They share £108 in the ratio of their ages. So that would be 5 to 6 to 7. You're splitting 108 into those parts. So you could draw it out 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, 6, 7. Okay, so that means in total, I'm splitting 108 into how many parts? 5 plus 6 plus 7 gives you 18. So I'm splitting 108 into 18 parts, which is 6. Okay, so each little part is 6 pounds. So therefore, to calculate how much each person got, you multiply their ratio by 6. So let's see who's first. Shania was first, so she's got 5 times 6, which is £30. Michaela is next, so she would be the 6th part of the ratio. Ratios, if you're not told who's who, it's always done like whoever's mentioned first, they go to the first part, whoever's second, they have a second ratio. So Michaela, 6 times 6 is 36, and then Annie, last but not least, 6 times by 7 is 42. Now you can double check to make sure you've got it right by just adding them all together. So 42 plus 36 plus 30 is 108. You know you've done it right. And the question is talking about Annie. So Annie gives 1/3 of her share to her mother. So 42 is split into 3 parts. So 42 divided by 3 is 14. So she gives £14 to her mother. So how much is she left with? She is left with 42 take 14 is £28. Okay, now next ratio question. The cost of a holiday is £3,500. Ellie pays a deposit followed by 6 equal monthly payments in the ratio 2 to 5. Okay, so we know we've split £3,500 in the ratio 2 to 5 parts. So 1, 2, 3, 4, 5. So in total, how many parts are we splitting 3,500 by? We're splitting it into 7 parts. So 3,500 divided by 7 is 500. So each part is worth 500. So therefore, you know that her deposit was £1,000. The deposit is £1,000. Okay, which must mean that she's left with £2,500 left to pay. Okay, now we know that her deposit is paid and then she makes 6 equal monthly payments. So that means that the 2,500 needs to be split into 6. So we just do 2,500 divided by 6 is £416.66. 416.66 recurring. So that's her monthly payment. 6 lots of that, and then she's off on her holiday. Okay, an outdoor adventure centre offers 3 activities: abseiling, kayaking, rock climbing. Each day you can only take part in 1 activity. On Saturday, 40 people visit the centre to do the activities in the ratio 4 to 1 to 3. So 1, 2, 3, 4 to 1 to 3. So how many parts in total? That's 8. So 40 divided by 8 is 5. So each part is worth 5. So that must mean that abseiling was 20 people, kayaking was just 5, and rock climbing was 15. Sorry. And then the next day, 50 people visit the centre in the ratio 2, 1, 2, 3, 4, 5 to 3. So we do 50 split into 10 parts. So once again, that's 5 for each part. So therefore, the people on Sunday is 10 for abseiling, 1, 2, 3, 4, 5 times 5 is 25 for kayaking, and 15 for rock climbing. On Saturday, it's 20, 5 and 15. So we need to complete a bar chart. A bar chart to show you this information. So, bar chart. Okay, so over here we'd have our frequency along this axis. That just means how many people attended. So the maximum amount was 25, so we could go up in 5s. 5, 10, 15, 20, 25. 0. And it's a bar chart, so let's see, do we have enough space? 1, 2, 3, yeah. Okay, so on the Saturday, and then the Sunday, so 1, 2, 3. Now we're going to want a key because it's a bar chart, so I'll just do it in different colours, but you could do it in different shades when you do it. So on Saturday, the abseiling, let's do the key over here, pink is abseiling, is 20. So I draw a graph up to 20. So that's abseiling on the Saturday, and then on the Sunday, how many abseils? 10. So go up to 10. Then let's do a different colour for kayaking. So second one is kayaking. So kayaking on the first day, there's 5. And then on the Sunday, there's 25. Clearly, Sunday must have been a nice warm day. And then finally, we've got 15, 15. Oh, okay, so 15 on both days. So just draw it like that, 15 and 15. Now be careful when you're doing a bar chart. So you need your key, if it's a bar chart like this. Let's just label it to climbing. You need to label each axis, so day of the week, and then you say which one's which, Saturday, Sunday. And you need to label your axes. Did I already say that? Okay, then it says, what fraction of the visitors chose rock climbing as their activity over the weekend? So in total, there were 90 visitors, 40 plus 50. And rock climbing was the third one, so 15 plus 15 is 30. So that would simplify to 3/9, which would simplify to a third. So a third of everyone chose rock climbing. Very fun activity. Okay, average speed. So what's the formula for speed, distance, time? We know that speed, if you watched the previous video, is distance over time. So Pavlos drives 150 miles, that's your distance, in 6 hours, that's your time. He drives the first 20 miles at an average speed of 38 miles per hour. Okay, I thought this was going to be a lot harder than it is. Work out his average speed for the rest of the journey. So if he's already travelled 20 miles, that's leaves him with 130 miles to travel. Oh no, it is, because we need to figure out how long he's travelled for. Okay, I did think it was too easy. Okay, so he's got 130 miles left. Now we need to figure out how long his how long it took him to drive those 20 miles. So speed is 20. No, speed is 38 equals distance, which is 20 over time, which we don't know. So I've just substituted these values into that formula here. I can rearrange it. So times both sides by t. 38t is 20. And then divide both sides by 38. So the time would be 20 over 38, which is 20 over 38 is, oh, this is nasty. Okay, 0.5263 recurring hours. Now remember, hours always need to be written in terms of time. I'd say it's fine to just leave it to 4 decimal places. You ideally write all of it out. So time is 0.5623 hours. Okay, so how much time is he left with? So we do 6 take away 20 over 38, which leaves us with time left is 5.47368421, blah, 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 a really ugly number in the exam. Hopefully you won't have a number as ugly as this, but if you do, just use the answer button on your calculator as it stores it. So work out his average speed for the rest of his journey. So we know speed equals distance, which is, let's do it in a different color actually. So speed is distance, which we said is 130 over time. Now you could write 5.4, just leave it as answer. If you don't know how to do that, then write the whole thing out and write it underneath. So speed is 130. So you write it as a fraction, and then over here is just your answer button, and it saves the last thing that was in the calculator. So 130 divided by answer is 23.75. That is a very slow speed, but hey, perhaps it was all through towns. Okay, so his average speed was 23.75 miles per hour. Okay, next we've got a percentage increase. So Marco owns a business. In April, he receives 1,230 orders. And then he launches a sale, has a big influx of sales, and we want to figure out what the percentage increase. Now, generally, whether it's for a percentage increase or a percentage decrease, the formula for working out percentage change is, my brain's gone blank, is the new value, the difference, okay, so the difference between new and old value over the old value, so that's like the original, times by 100. So in this case, we've got, what's the difference between 1,860 and 1,260? 1,860 take 1,230 is 630 over, what's his original? 1,230, and times it by 100. So 630 divided by 1,230 times by 100 is 51.21951. So its percentage increase is 51.2%. Okay, so percentage change, whether it's an increase or decrease, it's the difference between the new and the old value divided by the old value. The old is just the original, the first value, and then times it by 100. Last question. Oh, that's an easy one. Okay, right, 33 over 45 is the percentage. Okay, this is just, you know, I mean, it's a calculator paper, so let the calculator do all the work for you. What does a fraction mean? It means, well, that's the divisor line, so that means 33 divided by 45. So type that into your calculator to get a decimal. 33 divided by 45 is 0.73 recurring. How do you turn a decimal into a fraction? You simply times it by 100. So once again, you can do this on your calculator if you want, but times it by 100, that would be 73.3 recurring. Okay, and that's all you do to turn a fraction into a percentage, turn it into a decimal, and times it by 100. And on your calculator, you don't even need to do the dividing. You can just write it on your fraction button as 33 over 45, and it does the hard work for you. Press the SD button and then times by 100. And that is it for ratio. Okay, so statistics and probability. Let's do it in one fell sweep. So here we've got a two-way table. All that means is that it's collected data about two different things. So in this case, the number of tablets and mobile phones in 60 households. So, question asks us, how many households have 3 mobile phones? Okay, so this is the column for 3 mobile phones. So 6, so maybe that normally would have been like highlighted so that it's separate. Okay, so 6 households have 3 mobile phones and 0 tablets. 7 have 3 mobile phones and 1 tablet. 8 have 3 and 2, and 2 have 3 and 3. So all I need to do, this whole column is all of the households that have 3 mobile phones. So I add them together. 6 plus 7 plus 8 plus 2, which is 10 plus 7 is 17 plus 6 is 23. Okay, so just add them together. I'm just going to double check with the calculator because I'm not feeling very well, so I don't want that to. 6 plus 7 plus 8 plus 2 is 23. Okay. How many households have more tablets than mobile phones? Okay, so more tablets than mobile phones. So if I have 0 mobile phones and 0 tablets, that is not more tablets. If I have 1 mobile phone and 0 tablets, I have more mobile phones than tablets. If I have 2 mobile phones and 0 tablets, I have more mobile phones. So all of that has to be crossed out. How many so more tablets than are mobile phones. So if I have 1 tablet and no mobile phones, that is not that's more tablets than mobile phones, right? If I have 1 tablet and 1 mobile phone, that's not more. If I have 1 tablet and 2 mobile phones, that's not more again. So I cross all of that out. If I had 2 tablets and no mobile phones, then that is more than mobile phones. If I had 2 tablets and 1 mobile phone, that's also more. 2 tablets and 2 mobile phones, no. If I had 3 tablets and no mobile phones, that's more. 3 tablets and 1 mobile phone, that's more tablets than mobile phones. If I had 3 tablets and 2 mobile phones, that's also more. So all of those count. So let's add them together. 8 plus 1 plus 1, I don't need to add the zeros, is 10 households. Okay, then we've got a vertical line diagram. So all that means is the top of the line is where the top of your frequency is. So the diagram below shows the number of fruits a group of students eat in each day. It doesn't tell us how many students there are, so we're going to need to find that out. And we need to work out the mean. So first of all, let's start by finding out how many people. So that is 4. So 4 students eat 1 fruit. Then that's 7, that's 5, and that's 2, and that's 1. So then 2 fruits are eaten by 7 students. So you could set up yourself a little frequency table. So frequency, number of students that eat that fruit, and therefore total fruit eaten. So the frequency for the first one, 0, no students eat 0 fruit. So 1 fruit, 4 students eat 1 piece of fruit. So in total, that's 4 fruits that have been eaten. Then so we're saying, let's just call that number of fruits. Number of fruits. Okay, so 2 fruits are eaten by 7 students. So in total, that's 14 fruits that have been eaten. 3 fruits are eaten by 7 students. So 3 times 7 is 21. 4 fruits are eaten by 5 students. So 4 times 5 is 20. That's 20 fruits in total. 5 fruits are eaten by 2 students. So that's 10 fruits in total. And 6 fruits are eaten by 1 student, so that's 6 fruits in total. So this is kind of like working out the mean from a frequency table. You've just drawn your own kind of frequency table. And how do you work out the mean? You add all the values together and divide by how many there are. So how many students have been asked? Let's figure that out first. So 4 plus 7 plus 7 plus 5 plus 2 plus 1 is 26. So 26 students in total. You could have also worked that out by just adding these two, so the lengths of the vertical line chart. So the mean is the total number divided by the the amount. So another way you could have done it if you didn't want to draw out a diagram is here, you know, you've got 1 fruit is eaten by 4 students, so that's like 4 fruits in total. You know, 2 fruits are eaten by 7 students, so 2 times 7 is 14 in total. 3 times 7 is 21. 4 times 5 is 20. 5 times 2 is 10, and 6 times 1 is 6. So that just tells you the total number of fruits eaten. So the mean is the total number of fruits eaten. So we add up either the last column here or the what I've just worked out. So 4 plus 14 plus 21 plus 20 plus 10 plus 6 is 75. And we worked out that there are 26 students in total. So you do 75 divided by 26, which is 2.884. But let's just run it to 2.9 to 1 decimal place. With a mean, you're generally going to get a decimal answer. So people sometimes think that it's wrong because it's a decimal, but it's the mean. So it's generally going to be a decimal answer. And over here, we've got bar charts. So table shows information about animals in a petting zoo. The first thing that we need to know about bar charts, or the thing that we need to remember, is label your axes. Okay, people always forget that. What else? You need equal gaps between your charts. So let's see if we can do that. So let's label on axes. We'll do it in black pen. So going that way, going that way. That won't be continuous. We don't need the arrow because it's just discrete data. So the highest number is 7. So 0, 1, 2, 3, 4, 5, 6, 7. And this axis is going to be called number of animals, or you could have called it the frequency. It's up to you. And then over here, we'd say type of animal. And there's not enough room. I think I should have put it over there, but hey, whatever. So alpaca, how many alpacas do we have? 5. So alpaca over here. Rabbit, 7. And you write rabbit under here. Then goats is 3, so you go up to 3. And you write goats. And then piglets is 4, so you write piglets here. So remember, it's not just enough to label each bar. You label each bar, but you also have to give the the axes a name. Okay, so label your axes. Make sure that there's equal gaps. So if you left no gaps, then you can't leave any gaps for anything. But make sure there's equal gaps between the axes and the bars, and each of the bars as well. And also make sure that the bars themselves are the same width. Okay, and then moving on to probability, the last 2 questions of this thing is a frequency tree and an estimate of a probability. So 300 people entered a swimming competition, which is shown over here. So with a frequency tree, the thing is, everything is going to always add up to the first little bubble that you have. Then each bubble here, it needs to also add up to the original. So like these 2 must add up to make 300. And all of these 4 all together must also add up to make 300, which is the total. So 300 people were entered in a swimming competition. 190 were women and the rest were men. So I know I can write 190 here because 190 were women. The rest were men. Well, 300 take 190 is 110. So that must mean that 110 were men, because these 2 little bubbles need to add to make 300, which is the total. I'm told that 80% of the women completed the competition. So over here is women that have completed. So I need to work out 80% of 190. So 190 times by 0.8, or you do whichever way works best for you. As it's calculated, the multiply method is great. So 152 women completed the competition, which must mean that 190 take 152 is 38. 38 did not complete the competition. So hopefully you can see that these 2, they add to make 300. And these two here must add to make 190. So each branch, like each little thing that branches off, it needs to make up the thing before it. So these two here are going to need to add up to make 110. Now we're told that 40 men did not complete the competition. So the only thing I have is to work this out. Well, I know that 40 plus something adds up to make 110. So I could just do 110 take 40, which is 70. Now to double check that I've done it right, let's add all of these up together. 152 plus 38 plus 70 plus 40. What should they add up to? Well, everything should always add up to the original. So this should add up to 300. This should add up to 300. So let's see if it does. 152 plus 38 plus 70 plus 40 is 300. So yes, we've done it. Okay, next, on a biased dice, the probability of getting a 4 is 0.6. A biased dice means it's not fair. It means it's been like fiddled with so that it's more likely to land on something than something else. And we need to estimate the probability. Now, when we are estimating a probability, all we do is we multiply the relative frequency, which means the chance of it happening. So probability of it happening times by the number of trials. Okay, so in this case, the probability of it happening is 0.6, and I roll the dice 450 times. So I just do 0.6 times by 450. And that gives me 270, and that is an estimate for my probability. So that is it. Thank you for watching, and well done for making it this far, and good luck for your exam tomorrow.